Well, good morning, everybody. I'm Professor Stephan Matthai and leader of the civil engineering discipline in the infrastructure engineering department, and I welcome you to this information session on civil and structural engineering. It's glad you made it here in spite of the weather. I think it's probably one of the worst days in the whole year with sleet and hail, but it's good to be inside and take in some of this information, and it'll be great to discuss with you about our program as we go along in the day. So let me start by giving you a bit of an introduction into civil engineering as such, as a subject in the 21st century, the standing of the University of Melbourne, and also the course offerings that we have here at the university. So you may have all heard about international university rankings, and there is a ranking that started out from the Times Higher Education supplement in the UK, and then these guys got together with some professional headhunter offices, Quaterni and Macmillan, and then they came up with this ranking which recognizes the University of Melbourne as #1 university in Australia, and our civil and structural engineering department as such, as a discipline, as number 27 in the world. So that's quite an accomplishment for a small country like Australia. Small in terms of numbers, not small in terms of areal extent. So you have here really one of the top universities in the world, and this comes together with a higher level of qualification that you can earn from this university, and a degree that is recognized internationally. So a degree that is transferable. You can take this degree and it will be acknowledged whether you go to Europe, Africa, South America, or the US. So what other advantages do come with this? Well, to start with, when you have a lot of top leading scientists from all around the world whom you can interact with in your degree courses. There's a lot of elective subjects where you can pursue beyond the sort of core curriculum special interests just because of the size of this university and the breadth. Yeah, we have a comprehensive university. We're not just engineering, we have the humanities as well. So there's lots of offerings. We are industry connected. So in fact, we are recognized as the #7 in the world university in terms of the employability of its graduates, which is quite outstanding as well. We have good industry contacts all around the world, and we offer internships as part of the curriculum. In fact, this is part of the accreditation that you will undergo when you conduct your degree. And as I said, the courses are internationally recognized. So there's a compliance with the Washington Accord here on engineering. And you have a lot of flexibility there in terms of electives and in terms of going for particular specialization areas over the degree course. And I will come back to this when we talk about the overall structure of the degree. So let me take a step back now and talk about civil engineering as a whole, because I think you need also a bit of an introduction to the subject. So what is actually civil engineering? And of course, civil engineering is anything but military engineering, so it's a very broad discipline. But the definition is a bit more narrow when we come to actually what we are doing here in our department. So civil engineering refers first to the built environment, and these are, of course, all kinds of infrastructures and the materials that we need to build this new infrastructure, whether this is running shoes made from recycled plastic, or whether these are special thermal insulation panels for houses, road surfaces that contain old tires and whatnot. So the built environment, planning, designing, constructing, monitoring, and maintenance. And I have here the Aqueduc de Millau on the right-hand side. And this bridge is actually not so far in terms of its design from the bridge that was designed by Morandi in Genoa and collapsed just a few days ago. So maintenance is a very important feature. And maintenance means that you understand the design decisions that were made when you build a particular piece of infrastructure. You want to build infrastructure that's fit for extreme events, and I'll come back to that in the context of discussing the role of simulation in civil engineering. We want to restore infrastructure after natural disasters like the earthquake that shook the Himalayan regions and destroyed so much houses. And we've sort of delivered here an opportunity to build prefabricated housing and supply that at a low cost. So things like that. Project management, which is a major issue. Take, for instance, the Norwegian House of Parliament that was tendered at 40 million and cost 400 million in the end. So project management is a major issue. Transport, where we have here the AIMS project. So we have that whole area around Lygon Street instrumented now, and we monitor the traffic flow, the air quality, the people movement, just to collect some data and see how all of these things tie together and how we're dealing with peak hour loads. And then on the other hand, the engineering of the natural environment. There's never been that much competition for the natural environment as we have today. We have people, we have agriculture to start with irrigation. We have hot springs and thermal baths. We have fracking in the deeper subsurface. We have waste repositories. We have all of these things, but our traditional legislation legislates every one of these things separately. In reality, they're intertwined. Hydrology in an urban area is really the interplay between the water flowing through the rocks and through the soils and the water that is flowing through stormwater drainage pipes, for instance. So understanding all of these things together belongs to engineering the natural environment. And these competing land uses are a big topic of today. So I mentioned water resources, geothermal energy extraction, fossil fuels, carbon geosequestration to offset the CO2, the 32 gigatons of CO2 we put into the atmosphere every year now, and other environmental engineering objectives. Finally, and civil engineers also provide services in many contexts. And that may be just through government in evaluating engineering projects, but it may also be through service companies that provide these services. And I mentioned already also the links that exist to the humanities. And we're here in a special position to work on that because we have this Institute of Public Policy with whom we are collaborating. And this is, of course, where new laws are made, and these laws really determine our future. So what is 21st century engineering? Where are we at in engineering in this century as opposed to the last century? And my personal opinion is here that the main difference is that we've just gone away from purely experimental work and analytical work, where we found mathematics for isolated parts of systems, to a situation where we're almost confronted with complexity. Whether it's when we are trying to engineer an autonomous vehicle, like a self-driving car, you're responsible, but the thing drives by itself, or whether we are thinking about large, complex engineering projects where we're engineering for certain goals, but the outcomes always involve sort of side effects that we didn't anticipate. So the what of complex systems engineering is really that we want to reproduce the behavior of interest in computer simulations before we actually build the structure. And the goal is really to understand this complexity and predict its present and future system behavior from sparse observations. If you think now about long-term projects like storing CO2 in the subsurface, what are our oldest engineering structures in the world? They're just a few thousand years old. But we want to engineer something that is safe for 50,000 years or 100,000 years. So these are new challenges that we can't address with experiments without the use of computer simulation. So with the simulations, we can do what-if analysis of natural and engineered systems. And we can take this forward to become aware at an early stage and eliminate the side effects of engineering measures that we didn't bargain for. So we can carry out uncertainty analysis, we can do design optimization of systems performance and its sustainability, and we will take that next step to cyber-physical systems. And an autonomous vehicle is a cyber-physical system where there's basically a computer between the driver and the road, and the computer says, yeah, you can do this, or you cannot do this because it's not safe. Yeah? So there's more and more things that come along. And maybe you may argue that you don't want that for a car, but if you drive a large crane and you're tired in the afternoon and you don't want a container to bump into a ship or a harbor building, then of course this becomes very important. And into this belongs also the assimilation of monitoring data, as we do here in this AIMS project I described, the ones on the monitoring of the Lygon Street district. And the how, of course, here revolves around software engineering. So we engineer our own tools for these purposes. And this is a very, very rapidly growing area. Goal-based simulation is a new way of doing simulations where basically the user defines the accuracy of the outcomes and the tool then achieves these outcomes. This revolves around high-performance computing. I mean, there are industry consortia with whom we work in trying to test this technology. So we have champions in the research labs of international companies who use this technology, and then this technology eventually becomes the technology that you use. And there's a tradition in all important engineering schools in the world of this process. So yeah, so software development is one part of this engineering that supports all of these activities, and the examples I've shown on the right-hand side relate to things that we have done in this context. And with the showcases and benchmarks, we can show that this technology does make indeed a difference, and this is of course key for the market uptake of such technology. And in doing this, we collaborate internationally to achieve these outcomes. So what about employability? What about careers in civil engineering? So look at the right-hand graph here, where the 10 most competitive engineering disciplines are plotted. And the upper bar is basically material science, where there is the largest number of applicants for the smallest number of jobs. Yeah? So it's extremely competitive. And when you look here at the bottom of the scale, there is civil engineering. So there you can pick and choose. So it's really a great area to be in because there is such a high demand. It's not that it's less challenging to do civil versus material science, but there is just such a big demand as we are transforming our infrastructure from the last century into infrastructure of this century. And again here, an infrastructure engineering that revolves around buildings, roads, bridges, railways, airports, and you can just see it at the front of the university where we are getting this nice new underground station being built, but also all the other projects like the tunnel that will be built here in Melbourne. And some of you have seen or experienced the congestion that we are dealing with and we want to overcome, of course. So there are a lot of challenges in this area. But in terms of the other civil engineering that we have here at the University of Melbourne, we do have, of course, materials engineering, geotechnical and soil engineering, water resources with a large group in our department, engineering for government in terms of a consulting role, in terms of compatibility with infrastructure or resilience against extreme events. And we have, in fact, a center for disaster management. And finally, petroleum engineering, which is also an important area of engineering in the civil space, and it offers at the moment the highest paid jobs. So yeah, in terms of our employability, I already pointed out that we are ranked as number 7 worldwide in terms of employability. And there's a reason for that. And if you look here at our program, you can see here a number of features like internships, where our students actually go out in the industry and learn what sort of the practical needs are and why the things they learn are relevant. So that's a part of the education. The connections with industry, and this is reflected in many events we have with industry representatives coming to the university, but also all the research projects that we have as academics in the university. We have career building workshops and employability workshops where again you get a chance of what the important things are that qualify you for a job in the workplace. And we have the clubs, the student clubs and societies that also often maintain excellent relationships with the industry through alumni networks and other features. And you may have seen advertisements about the Endeavour exhibition, where our students sort of feature things that they've engineered, and it's actually great fun. I mean, you have drones flying around and all kinds of displays. A very important other aspect of our education are labs. And labs are nowadays sort of key test beds for complex things like entire buildings, like prefabricated housing, but also like multi-physics experimentation as done here for porous media. So you try to understand how fluids flow through a rock, but all your understanding is at the same time tested by making a computer model of what you see in the physical experiment and seeing whether that computer model does indeed behave as the real world system in as much as we can see it in the experiment. And we do this here, of course, for buildings. We do it also in terms of spatial monitoring, sort of mapping rooms, and this mapping of existing infrastructure is a very important part, because there's a lot of old buildings for which we do not have plans anymore, or they have been modified many times. Now we want to change them, but first of all we have to take stock of what there is. We have to get their dimensions and all of that. And then another aspect is the non-destructive testing. What can you do to this bridge to see whether inside of that broken bridge there was like a steel beam that had corroded? How can you find out about that without drilling lots of holes in the bridge, compromising its perhaps still intact parts? So all of that revolves around these sort of imaging techniques. And then, of course, this whole portfolio of skills that our students acquire, in addition to the expertise in a particular subject area, has an impact on the employment outcomes. So there's currently a strengthening market for engineering and IT graduates. And I mentioned, of course, cyber-physical systems and this complex systems guiding engineering, which is what is happening at a very large scale all around the world. There's the economic growth. That is, of course, an important factor in all of this. And then we have here various programs that then prepare some students who have entrepreneurial ambitions to go straight into the workplace, like through the Melbourne Accelerator program and particular activities in the engineering and business streams, and entrepreneurship classes, maker spaces, hackathons. So trying to establish a culture like one that exists in the Silicon Valley around Stanford University, Berkeley, or up in the Boston area, to make some examples. So what happens to our students once they leave the university? Well, our civil engineering graduates have really careers here in Australia and all elsewhere in the world. And in terms of the industries, that they go to anything from construction, geotechnical engineering, so traditional disciplines, some manufacturing, oil and gas, so traditional disciplines, to other areas that are rapidly emerging, and many of them actually start their own companies with friends, or they work in smaller companies, because today it's so easy to start businesses. In terms of the companies that they work for, and here we're only listing some of the largest companies, they work for companies like BHP Billiton, sort of private-public partnerships like City West Water, large consulting companies like GHDT, other big companies here around Melbourne, but you can see from this selection of companies that consulting is an important area here. So smaller firms, and this is of course a great opportunity for you when you graduate, because in these smaller firms you get to do a bit of everything and you learn a lot of new things, and you can sense very rapidly that your contribution is important. So in terms of in these companies you have different job roles, and they may range from structural engineers, geotechnical engineers, so people who work really on particular site-specific studies, to people who then work in the management. I'm now moving on to the kind of degree streams that we have here. We have different bachelor degree streams that prepare you for the masters. And the program here works in a way where you do 3 years up to your bachelor's degree, and then you put another 2 years on top of it to get your master's qualification. And most of our students go for the master's because this is really a distinguishing element. You might do a master's in Monash, which only takes you 4 years, but you get here more breadth and more depth when you do the degree. And once you're in a job place, people expect you to produce and to deliver. So you have much less time to study and deepen your understanding. So it's better to spend yet another year at the university deepening your understanding, because when the going gets tough, the tough gets going. So yeah, we have these different entry points to the Masters of Engineering. And then we have a Masters of Engineering in Civil, a Masters of Engineering with a focus on structural. So civil being more general, being the natural environment, structural being the built environment, and also a Master of Engineering with business specialization, where you move towards the direction of project management. In the Bachelor of Design for civil systems, here's sort of a bit of a portfolio of the kinds of things that you learn about. So a lot of these things are fundamentals and skills. And you see that there is some space for electives, and breadth here means that you can really broaden out. And then in the master's program, you have some very applied courses with a lot of projects in the courses where you take this knowledge. We call these things capstone subjects, where you then apply your knowledge to engineer as small teams particular structures, like for instance a water supply or other kinds of pieces of infrastructure, that then that is teamwork that prepares you really for the workplace. And this is also true for the Masters of Business with the specialization. So in order to do all of this, you may wonder of how you finance your studies and what scholarships are available. And this is just sort of a very brief overview as I'm running out of time. You have the Commonwealth supported places, and a new thing in there are these sort of Victorian tertiary admissions center supported graduate packages. They are for you if you're a gifted student, so you can get funding from them. There are the general Commonwealth supported places. There are the Australian fee places, where you basically you pay some of your money back at a later point in time. And then there are also other forms of scholarships that you may be eligible for, and we are happy to discuss this in these sort of individual sessions, not in this big one, because this would be lots of detailed information. So I conclude with thanking you again for your interest. I think it's a great thing to study civil engineering, although it might not be as sexy as some other subjects may seem at first sight, but it will really pay off. And it will also give you the feeling that you're making a contribution. If you're a good engineer, you do things to improve our human condition, our living environment. And I think that's a challenge you want to embrace, and that's really something that gives you meaning in life, in addition to learning something interesting.